I am Seshagiri Rao, Associate Professor in the Department of Electronics and Communication Engineering. I am going to discuss about the CMOS inverter characteristics using Cadence software. So I have opened this folder beyond lab recording. So in that, I will open the terminal. So I have typed CSH first, then followed by source gap home / install / CSH RC. Then I have typed virtuoso and then press enter. Then window will appear with some delay. So I have to wait till menu comes on this small bottom window. So let me click the file. Then new library I will create. So the new library is going to be experiment 2. And I have attached to technology library. Then press apply. I will select GPDK 180. So here you get a message that experiment 2 successfully attached to the technology library GPDK 180. Then click OK. Then again press File, then New, then Cell View, and this cell view should come in the experiment 2. So I will select experiment 2, and in this the cell is going to be the CMOS inverter. Then window will appear, and in this I will draw the P MOSFET, N MOSFET, and do the necessary interconnections for the simulation. So create instance. I will select the P MOSFET and the N MOSFET from the GPDK 180 library. So N MOSFET I have selected. I will position the N MOSFET here. Then I will press escape so that this is going to vanish. Then create instance for the P MOSFET. PMOS. So I have selected the P MOSFET. Press escape. Okay. Then I have to do the necessary interconnections. After incorporating the supply voltages VDD and the ground. So for that, create instance. I will go to the analog library. In that, I will take the VDD. So this is it represents VDD. So VDD I have positioned it here. Next, I need a ground. Let me type ground, it is going to come automatically. So here ground A and ground D have come. I am going to select ground. So this is a ground, and this ground I am going to position it to the window in this way. Then I will use the thin wire to make the required connections. So both the gates of P MOSFET and N MOSFET are shorted, and the drain of P MOSFET is shorted to the drain of the N MOSFET. Okay. Now I will create the input and the output pins. So create pin. So I will give the VIN for the input pin, VIN, and the direction is input. So it has come. So this is the pin, and I will position it here. Similarly, I will create the output pin, create pin, direction, output, name, Vout. So this is a Vout, and I will make the required connections. And of course, we have to connect the source to the substrate, both for the N MOSFET and the P MOSFET. Otherwise, that is going to show errors. See, check and save. It is showing two warnings because I have not made source to the substrate connection. This is a substrate. The middle line is the substrate. This top one with the arrow is the source. For P MOSFET, the source, the arrow is inside. For N MOSFET, the arrow is outside. So I have to make these connections so that these warnings also will disappear. And but here also I am connecting this body to the substrate. Now I will check and save. See, now there are no warnings. Everything is okay. Now I will supply voltage VDD, which is 1.8 volts separately. And here I will put a voltage source. So for that, create instance, then V pulse. So this is a V pulse, and here V pulse, I have to select the properties of V pulse. Period I will select of 1 millisecond. Period I will select as 1 millisecond, and the pulse width I will take it as 0.5 milliseconds. And this requires two levels of voltages. So one is 0 volts and another is 1.8. So with these characteristics, this pulse generator is available. So I am going to position the pulse generator here. And I will connect this pulse generator to the circuit. And this point here I have to put the ground. So I will make connection from here to the ground. And VDD I have to give 1.8 volts. So for that, I will make a separate arrangement. And the ground also I will take, copy. You can separately call this VDD and the ground from the create radio button, because they are already created here. I am just copying them. So how to copy? Just click on that, then red will come, then press C, then click on this, then you can take wherever you want. Otherwise, again you can go to create, then instance, then you can type the ground and take the ground like this. Okay, first time it takes more time, later on you can simply copy and paste. And here I have to put a voltage source with value 1.8 volts. Create instance. VDC. So what is the value? I will take 1.8 volts. Why 1.8 volts? Because I am using DPDK 180. So this is 1.8 volts, and I have to connect ground to this. So this is the circuit. Let me again check and save. So there are no errors. The circuit is ready for testing. So how do I test it? I will see the transient response, and I will also see the transfer characteristic also I will verify. Okay. So for that we have to go to launch, then ADEL, then analyze, choose transfer characteristic. So I have my period of the waveform is 1 millisecond. So I will take 5 milliseconds here. Then moderate, apply, okay. Then I have to see the outputs. Where I have to see the outputs? I have to see the input voltage versus the output voltage. So to be plotted, select on design. So this is one parameter I will take, and this is another parameter. So these are the two things which I have to plot: V out versus V in. Now I will press run. See here now the waveforms are available, but these waveforms are merged. So I have to separate these waveforms. For that, I will click this button. So once I click this, these waveforms are separated. So this is V in. What you are seeing, this is the V in, and this is the V out. See, when V in is 1, V out is 0. And when V in is 0, V out is 1. So this is acting like an inverter. Now let us see the transfer characteristics of this. To see the transfer characteristics, I have to press analyze, then choose, then I should press here DC, then save DC operating point, then component parameter, select component. So I am going to select this component. I have selected the component. Then after that, I will select DC voltage, then press OK. So I have selected this component V0, and this V0 voltage I will vary from 0 to 1.8 volts, and then monitor the output voltage. So by this way, I am going to generate the transfer characteristic. So I have selected the component. Select component. So this is a component I have selected. This is a voltage. Okay. Then this voltage I should vary from 0 to 1.8 volts. Apply. Okay. So then I should check the transfer characteristic by clicking this green button. So you can see here when the transfer characteristic will appear like this. You can see here this is high voltage and this is the low voltage. It is going to come in this way. So this is how we can measure the transfer characteristic as well as the output characteristics of CMOS inverter. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.